Hello to each and everyone. My name is Karan Gupta, and today I'm here to tell you about AI, machine learning, deep learning, neural networks, or something more multi-layered neural networks. Actually, this session is all about the very basic. If someone is trying to enter into this field, they will really get to know what exactly AI, ML, and each and everything is. If you are literally nowhere, don't know about anything, you will really find this useful. I will, at the end of this video, I will try to let you know, guys, some of the examples and where I'm heading this particular session. So you can take it towards your domain expertise, but I will take it to a domain expertise that I will be showing what exactly I have and why I have a motivation towards learning this AI and this machine learning algorithms. So first come first, what exactly is AI? Like it's a really trending word right now. We have seen OpenAI and right now we have DeepSeek, correct? So this is something like crazy what is happening in around us, and everyone wants to understand this. So why not quickly understand each and everything? So what exactly is AI? So AI is simply a artificial intelligence. So it is something called an application. What exactly a developer or a person has to develop that can perform the task on its own. I mean, it doesn't need any human intervention. For example, if I have been trained to do coding, so this is what I trained a model to do the coding. And if my boss asks me to change something like that, this is not what I want. I want AI to do everything itself. Okay. So this is what exactly the main goal of AI, and this is what exactly we need. When we talk about subset, then we have machine learning algorithms. So these are the training sets. So let's understand what exactly machine learning. So AI is a very quick overview, and one of the subset of AI is machine learning. So machine learning is a concept where we have a data. So let's say right now we have a lot of data. So every company has a lot of data because of so much advancement that we are heading right now in this era. So we have a data. So what exactly data includes? It includes all the variables, or let's say the features. Those are so-called the independent features, or let's say the input values. And what exactly we need? The output values as target. So we have independent variables as x1, x2, x3. So let's say today is a sunny weather. That sunny weather, sunny is again one of the feature independent variable. Now we can talk about the temperature. Temperature can be in another variable. So these are so many variables. And the target, like what exactly I need output is whether I will be playing the game or not, yes or no. That's what my target is. So let's say this is what the data we have. Now what we do, we divide. So this is a long series of data. It's not like 2 or 3 rows. We have 1,000 rows, 2,000, millions of rows. Okay. So now what exactly we have to do, we divide this data set into two parts. One of them is the training part, and another one is the test data. So the rule of thumb is like you divide like 70 to 80% as the training and 20 to 30% as the test. So what exactly we do with these machine learning algorithms, they try to train the data set. Once they train the data set, how they train? Okay, if it is a sunny and the temperature is 30 degrees Celsius, yes, I will be going for like doing a sports and other. Yes, I will be going. If a sunny but the temperature is even very low, then no. So this is what exactly they take a different features and then try to train the data. Now, what exactly these algorithms are based on simple statistical tools. Like we know about linear regression, correct? Like us, let's say we have so many data points and we get a linear line. So x is directly proportional to y. So this is what exactly we can train with some of the data set. And now what's next? So whatsoever the training we do with the 70 to 80% of data set, we will try to check it with the test data. That is a 20 or 30%. Now, since we already know what is the answer, we also know what is the input. So we try to feed the input to the trained machine learning model and then try to check it out whether it is giving the correct output or not. That's what we check it. Just because we know the data, we know the answer. So once we say, like once we compare each and every values of target from the training as well as test data set, we understand the accuracy of the machine learning models. And then this is where like different machine learning algorithms comes into the action. Different algorithms take different variables, different techniques so as to prove the accuracy. Now, if I talk about machine learning algorithms, then we have so many like linear regression, logistic, then regression. So particularly this machine learning is further divided into supervised and unsupervised. So supervised is what exactly they used to do. They have like a regression problems, they have a classification problem. So what exactly regression? The output can be anything, can be any numbers or something. And classification is like they have a binary digits like 0 and 1s, or very constant terms, yes and no, or very small terms that you have to define. So this is what supervised learning is. Unsupervised learning is like a part of machine learning again, that tells you more about the concept of clustering the data, reduce the data set. This is different part of it. So when I talk about the supervised learning, we have like all this sort of decision trees, then random forest, and the bagging boosting, XGBoost, extreme gradient boost, and other boosts also. So I mean, these are different types of algorithms that will try to give you the good training data set, which means, let's say this is a training or testing I did at a particular data set. Within that data set, if some outliers or some other data comes into the action and as an input that neither I know, neither model knows, but model being trained, what exactly this AI will do? Okay, they will try to understand where exactly the outliers will fit and tries to give you the answer for it. This is what exactly the machine learning algorithms comes into the action. Now, first and foremost thing, we apply in journal these algorithms with the help of Python. So Python has a bunch of libraries. One of the libraries is dedicated to the machine learning. So let's say very simple, like NumPy is a numerical Python. So all the numerical things that we try to take into account are generally within this particular library. Okay, let's say numerical stuff, statics, algebra, linear algebra, each and everything. When we talk about pandas, so whenever we have a data frames like data, so that's where like pandas library come into the action, where we analyze the data. Matplotlib, how we can see easily the data like mathematical stuffs, correct, like bar graphs and each and everything. That's what exactly we do in Excel. Now we are doing the Python. So that's the matplot library. We try to import that library in journal. So when I talk about the machine learning, like supervised and unsupervised part, there is where the SI-kit learn, like sklearn library, and there we have all the like logistic regression, linear regression, classification algorithms, each and everything. Now we'll talk about another part of subset of machine learning, that is a deep learning. So why we need deep learning is all because right now we are human. We want an we want human outcomes. We want something, a model that predicts something like human do. For example, let's say if somebody is trying to touch me, I get a sensor. Okay, someone has touched me, or someone has put a cold temperature or hot temperature. So I got a sensor, and this is what goes into my neurons as a sensation. That's what deep learning algorithms, deep learning tries to do for us. What they do, they try to take as an input and try to understand whether it is a hot, it is a cold, it triggers, it activates, and then tell us, okay, remove it or put it. Okay, this is what the sensation, what exactly deep learning networks try to see. For example, I'm seeing you from your eyes, so this is what the input that I'm getting, then I'm processing it, and then my mind is generating a image like what I'm seeing right now in front of you. So this is what exactly deep learning used to do. And how they used to do, they have a lot of neural networks. So what exactly these neural networks used to do, they try to take an input, and they have a hidden layers. Okay, they have a weight functions inside them. So according to the weight function, they say yes or no. Okay, it is a cold, no, remove it. It is a hot, okay, let it stay there. So that's what they tries to trigger with the hidden layers, and then we get an output. So it is a, with the help of these deep learning networks, we mimic the human nature. That's what the robots are doing right now these days. So now we have a single layer. If the hidden layer is single, then single layered neural networks. If we have a multi-layered neural networks. Now where exactly we need, so one of the application is like the computer aided engineering. So like I have a domain expertise of that. So right now the advancement is going so ahead. If I can solve my partial differential equation, that is one of the important part of computer aided engineering. If I can solve that part with the help of this particular method, then which means I can try to input it into my softwares, and I don't have to do the simulations again and again, which means I can just simply change the parameters and my outcomes will be ready to check, ready to do. So this is where physics informed neural networks comes into the action, where the neural networks takes an advantage of the physics of the hidden layers that we have decided, and trying to solve the differential equations. That's what we needed for our computer aided engineering, for let's say structural analysis part. I don't have to do it again and again. I just trained my model in such a way that I only have to give some different inputs and the model can predict the outcomes. So this is a quick introduction about the machine learning, deep learning, neural networks, and how you can use different libraries. And also for deep learning libraries, make sure to import TensorFlows and PyTorch. Might be a lot of people knows about it. So we try to import them, try to solve it in Python, and that's how we train data. That's it. So let me know, guys, if you need a detailed introduction about all the algorithms. I will be readily available, as well as if someone is into the computer-aided engineering and there is some position called data scientist, I will be readily available to tell more about how we can use these algorithms and so on, use those things. So thank you very much. Have a nice day.